Hello children, in this video let's see the continuation of the topic overloading. Okay, so there are various devices used to prevent overloading and short circuit. Let us study about them. First, a safety device is called electric fuse. An electric fuse is a safety device which works on the principle of heating effect of electric current. Okay, so electric fuse is a safety device which works on the principle of heating effect of current. It breaks the electric circuit if there is an excess flow of current in the circuit. Okay, so in the last video we have seen about overloading and short circuit. Short circuit means there will be an excess flow of current in the circuit. Okay, so what is the use of this electric fuse means it will break the electric circuit if there is an excess flow of current in the circuit, which will prevent a possibility of catching electric fire and prevents damages to the electric appliance used. Okay, and here you can see in the picture, this is the electric fuse which we will use to prevent the damages which is caused due to the excess flow of current. So fuse consists of wire that is thin and has a low melting point. Okay, so the fuse wire is made of an alloy of tin and copper. When excess current flows in the circuit, the thin fuse wire which have low melting point gets overheated and melts, which will break the electric circuit and prevent damages to the electrical appliances. So here you can see in this picture, this is the electric fuse which has a thin wire. The thin wire is having a very low melting point. Okay, so when excess current flows in the circuit, the thin fuse wire gets overheated and it's melt, which will break the circuit and prevent damage to the electrical appliance. Understand children? Then next safety device which is used to prevent the overloading and short circuit is MCB. MCB means miniature circuit breaker. Nowadays miniature circuit breakers are used in place of fuse. So nowadays instead of electric fuses they are using miniature circuit breakers, that is MCB, which are used in place of fuses. Okay, these switches will turn off automatically when there is an excess flow of current. Okay, so when there is a flow of current beyond the limitation, then the switches will turn off automatically, and when the fault in the circuit is corrected, the MCB can be reset to the on position and the circuit gets completed once again. Okay, once the fault gets corrected, the MCB will be switched on and the current will flows like as usual. So this is the working principle of miniature circuit breaker. Okay, so when there is an excess flow of current, it will automatically turn off. Once the fault gets corrected, it will be automatically turn on and return to its position. Okay, then one more fuse which is used to prevent short circuit, that is cartridge fuse. Nowadays in some electronic items they are using cartridge fuses. Cartridge fuses also used extensively in industries, agriculture applications, and it is also used in the residential fuse panels and other equipments. Okay children, now let's learn about magnetic effect of electric current. So you have learned in the last video about heating effect of electric current. So this magnetic effect of electric current was first observed by a scientist called Hans Christian Ørsted. So he was the first person to notice the magnetic effect of electric current. Okay, so you have learned in magnet lesson the needle of the magnetic compass, it will points in the north south direction when it is at rest. Okay, so when a magnetic compass is kept close to a current carrying wire, the needle gets deflected. Okay, so what he done an experiment using magnetic compass and current carrying wire. Okay, so when he kept magnetic compass near to the current carrying wire, the needle in the magnetic compass gets deflected. Okay, so this was first noticed, this deflection of magnetic needle was first noticed by him, and so he discovered this is the magnetic this is due to the magnetic effect of electric current. So in electric current itself there is some magnetic effect. So this is the principle, or this is the story behind the magnetic effect of electric current. Okay children, so who is the person discovered magnetic effect of electric current? Hans Christian Ørsted. Okay, so he done experiment using magnetic compass and current carrying wire, and he kept current carrying wire near to the magnetic compass, and he observed that the needle in the magnetic compass gets deflection, and he said that the deflection of the compass needle is due to the magnetic effect of electric current. Now about electromagnet. Electric current can also be used to produce magnets. A magnet that is produced by passing an electric current through a coil of insulated wire wound around a soft iron bar is called as electromagnet. So now we can use electric current to produce magnets. Here you can see in the picture. So this is a coil which is insulated with a copper wire. Okay, and when electricity is passed through it, it will behave as a magnet, which is called as electromagnet. Okay, and the electromagnet or the magnetic effect of an electromagnet can be increased by increasing the number of turns of coil, or by increasing the strength of the electric current flowing through it. Okay, so electromagnet means we can make use by using a coil of insulated wire, and when electricity is passed through it, it will act as a magnet, which is called electromagnet. And the magnetic effect of electromagnet can be increased by increasing the number of turns of the coil, or by increasing the strength of current which we are passing through it. The cylindrical coil, which consists of a large number of turns of insulated wire, is called solenoid. Okay, so the cylindrical coil which consists of large number of turns of insulated wire is called solenoid. Now uses of electromagnet. Electromagnets are used in many electronic items like electric bulbs, electric fans, mixers, washing machines, etc. Okay, so the magnetic effect of electric current, or these electromagnets, it's used in many electrical items like electric bulbs, electric fans, mixers, washing machines, etc. It is also used to separate magnetic materials like iron from metal scrap. Okay, so you know when the metal scrap is fixed and there will be a magnetic effect. Yes, so this electromagnets is used to separate the magnetic materials like iron from metal scrap. Doctors also, they are using electromagnets to remove tiny iron particles which may have fallen into patient's eyes accidentally. So you know our organ, eye is a very sensitive organ in our body, isn't it? So doctors nowadays, they are using electromagnets to pick any or to remove the tiny iron particles which accidentally fallen into person's eyes. Then electromagnets, it's also used in medical science to cure certain ailments. It is also used to cure certain it is used in certain treatments in medical science. Okay, so these are some of the uses of electromagnet. Now let's learn about electric bell. So as I have already told, electric bell also what's based on the principle of magnetic effect of electric current. Okay, so electric bell is one of the most common application of electromagnets. In electric bell also we can see there will be an electromagnet. Okay, so electric bell is one of the most common application of electromagnets. It works on the principle of magnetic effect of electric current. Okay, so the working principle of electric bell is based on magnetic effect of electric current. Okay, so here you can see in this diagram, this is the structure of electric doorbell. It consists of electromagnet. So here you can see electromagnet, and there will be an iron strip, then hammer, then gong and switch. Okay, so these switch is here. Okay, so these are the components of electric bell. So what are the components? Electromagnet, iron strip, hammer, gong and switch. Now how it will work? When you press the switch of the bell, so we will press the switch of the bell. Okay, so what will happen? Electric current will flows into the electromagnet. So first the electric current will flows into the electromagnet. The electromagnet will attract the iron strip. So here you can see the iron strip. Yes, so when the electric current flows through the electromagnet, it will attract the iron strip, and the iron strip will be attached with the hammer. Yes, so which hits the gong. Okay, so once it will it will attract the iron strip containing hammer. The hammer will go and hits the gong, which will produce a sound. Okay, so this is the working principle of what? Electric bell. When the iron strip has moved to the electromagnet, it no longer touches the screw and the circuit breaks. Okay, the electromagnet now turns off and no longer attraction towards the iron strip. Okay, so the iron strip thus return to its initial position. Okay, so this can be repeated in a quick session. So once we will switch on the electric bulb, when we are pressing the switch of the electric bulb, the electromagnets, when current will be passed to the electromagnet, so the electromagnet will attract it towards the iron strips which is attached with the hammer, and the hammer will go and hit on the gong, which will produce a sound. Okay children, so this makes the bell ring continuously. Understand children? So this is working principle of electric bell, which works based on the principle of magnetic effect of electric current. I hope that you all understand about magnetic effect of electric current. If you have any doubt, you can ask. Thank you.